Hello, Ethan here, and today I will be making a penny battery. And so what you'll need is, you guessed it, pennies, cardboard, and zinc washers. I am also going to be using steel washers, which are right here, instead of zinc washers to test which one works better. We'll also be using a bowl of vinegar to soak the cardboard in, and then bowl of water to soak another pile of cardboard in to see which one works better. Okay, so here's my little setup. I got the zinc washers and the steel washers, and then I also have the pennies and the cardboard. Okay, so now here is the water, and over here is the vinegar. So I'm gonna put I only have 3, so apparently I don't have very much vinegar either, but it should be enough. I only have 3 in each pile, so I'm just going to put them in here to soak, and then I will continue. Okay, so I think that's pretty good for the soaked. Oh, okay, and then I'll take these out here. Okay, so these are the water ones. And as you can see, I just cut the cardboard into little penny-sized shapes. Oh, and here are the vinegar ones. Okay, so 3 per file. And that should be good. Okay, so now we're gonna start building the battery. Okay, so what we're gonna do is, since we're building 3, I'll just build them all side by side. We'll put pennies on the bottom of each one to begin with, and then we will put one cardboard on each, two from the vinegar and 2 from the water, and then 2 of them will put zinc plated washers. I forgot to mention that they're zinc plated only on the other 2. And then pennies. Okay, I'm gonna tape these together so they don't fall apart. Okay, so I just finished fixing up the batteries, because I needed to trim the cardboard so it wasn't touching each other right there. So, and if the cardboard touches, it won't work as well. Now I'm going to test which one is best. So we got the steel vinegar, the vinegar zinc, and the steel water, and the vinegar or the water zinc. I forgot to mention that these are just zinc plated washers, and that the steel washers are stainless steel washers. Now we're going to test how much volts each battery produces. Here we go. So the water and the zinc battery we'll see how much that produces by putting the positive reader on the penny side and the negative spokes thing on the zinc side. So it's producing 2.923 volts, which isn't bad. So that's almost 3 volts. So that should power an LED. And my LED is right here. So let's see. We get a tiny glow from that, so that's good. It does power it. Okay, so now we're gonna move on to the zinc and vinegar battery. Same thing with the prongs. Okay, now this one's reading 3.15 to 3.10. 0.10, sorry. So that will also power an LED, so that's not bad for a penny battery with only 3 pennies in it. That one gives you a nice bright glow. There we go. So that's pretty good. So that one produces a little more than the water and zinc, but they still both produce. So far the zinc ones are working out pretty good. So now we're gonna test the steel and vinegar one. Okay, so this one we're gonna put the prongs in the penny side and the zinc side, or the penny side and the steel side. And these ones only really produce, negative 0.17. Okay, so far I think it's the steel that's not letting it work. Okay, we're gonna try the steel and the water one, the water steel one. This probably won't work at all. For some reason I think this one is actually backwards, like you have to put the positive side on the steel and the negative side on the copper. So this one's only producing 0.07. So, well, it's kind of, yeah, this one's kind of like, it differs a lot. So I don't know if this one, I don't think this one really works at all. So it has to do something with the zinc. Okay, so the reason why I believe the steel batteries didn't work is because stainless steel and copper are both good cathodes, but zinc is a good anode, which means negative. So copper and steel would be positive, so zinc is negative, which means I think it would work if I used stainless steel rather than copper. So I'm gonna take apart one of the batteries, two of the batteries that I made. Okay, as you can see here, I took apart my 2 water batteries. So what I'm gonna do is I'm gonna put a stainless steel, and then a cardboard, and a zinc, and a stainless steel, and then a cardboard, and so on and so on. Okay, so here I got that now. Same thing as the penny battery, just you switch the pennies out with the stainless steel and you keep the zinc. So gonna see how much volts this one produces. We're gonna put the negative on the zinc and the positive on the stainless steel. Yep, there we go. This one does work. It gets, I mean, it doesn't work super well, but it does get all the way up to 2, so 2 volts. So that's really good. Well, it's pretty good. So we'll see if this can produce enough energy to power an LED, and it can't, but you know, 2 volts is pretty good. I'm sure if we combined it with another one of these, it will. The parts of the battery I had were the electrolyte, the cathode, and the anode. The electrolytes were the water and the vinegar. And the reason why I believe the water worked is because our water here in Calgary is slightly acidic. The cathode was the copper and the stainless steel, and the anode was the zinc. And the cardboard was used to absorb the electrolytes in a physical form, so I could put it into a physical battery so I wouldn't have to put it in a bowl or something. The voltage of the battery depends solely on the chemistry between the electrode and the electrolyte. This means that different materials provide different levels of voltage. The highest voltage can be achieved when the anode is strongly reactive to the electrolyte, and the cathode has a weak reactivity to the electrolyte it is immersed in. The battery generates an electric current when one electrode, the anode, dissolves more easily in the electrolyte than the other electrode, the cathode. The dissolved atoms enter the electrolyte as positive ions, leaving some excess electrons behind on the anode. When a wire connects between the anode and the cathode, the excess electrons redistribute themselves, and some of them flow through the wire, making an electric current. Thanks for watching my video.